Welcome to another video from McFatter Tech Musser. If you like these videos, please click subscribe.
Okay, so this is our Wireshark TCP Lab. We've already opened up our document from Wireshark or from Dropbox. We've talked about TCP a little bit. We're following the instructions. We went to the first link and we downloaded a copy of Alice in Wonderland. We saved that text as alice.txt. Then in the next step, we posted. We sent alice.txt to their web server, and we did a capture of that. And this is what we're seeing here. But there's a lot of information maybe that we don't want. If we scroll up here in this list of packets, there's 40.78, there's a lot of transmission of information that's not really relevant to what we're doing. I want to get rid of all the other information. So I'm going to go up to my display filter and I'm going to add a space after TCP, and I'm going to do two of the AND symbols. And space, and I'm going to do IP.addr, that's IP.adder, and then equals, and I'm going to type in the address. Oops, what happened to my, how'd that change up there? Okay, I'll have to retype it. I'm going to type in and IP.adder equals, and my IP address of 128.119.245.12. And press enter. And now it's only going to show me those conversations. I filtered out all that other stuff. It's only got to do with conversations to that web server using TCP. If I scroll down, I can still see my HTTP because HTTP uses TCP, right? And there's my post. But there's a lot more. Those conversations started a lot earlier, right? What did we need to do before we could connect to that web server? Or what did we need to do to be able to connect to that web server? What was the thing that had to happen before we could retrieve an email or send an email or get a web page or post our document? We had to make a connection to that resource first, right? We had to do the TCP three-way handshake. ACK, SYNACK, ACK. Anybody see that here? SYNACK, ACK. Anybody see that on their screen? If you scroll all the way to the top of your list of packets as they're being displayed, it's right there. SYNACK, ACK. In fact, there's multiple ones. But notice they're using port 80. This is to establish that HTTP transmission. We can see that they begin with sequence 0 and then sequence 1. And then here's another one down here, sequence 711. Sequence 1, acknowledgement 1. Sequence 0, acknowledgement 1. Sequence 711, acknowledgement 1. Sequence 1, acknowledgement 711. Look at this. This is backward. This is here. This is sending to that web server, and here's them acknowledging it. So on my 4207 packet number, I sent a packet, and on packet 4216, the web server acknowledged it. So This is how we can see information from a live capture, and we can filter out all the information that we don't want. Was everybody successful in doing that? Anybody had any problems uploading and getting that capture? Okay. Now what we're going to do is we're going to load up our packet capture that we already have. So I'm going to go back to my Dropbox. Actually, first, you know what? I'm going to look in my downloads folder and see if I have a TCP for that. See, I got the 8.1 traces, but I don't have the old ones. So what I'm going to ask everybody to do is there in that Dropbox, download the first one that says Wireshark-traces zip. Download that. We're going to have a second set of packet captures. This is actually an older set. I'm going to then navigate to the folder. I click the little up arrow. I'm going to go show in folder. I'm going to right click. I'm going to say extract all, but I'm going to change the name on the end. I'm going to name it 8. I'm just going to give the number 8 on the end of it and say extract. That way I know it's different than the 8.1. So there's my Wireshark traces 8. I can close my File Explorer. In Wireshark, if everybody still have the capture on their screen? Did anybody close out of their capture yet? I want you to take a screenshot of that capture. Just take a screenshot of your whole screen and let's paste that into to show that we did the live capture. So I'm just going to do a print screen. I'm just going to paste that into my document. We're going to do that before we start step 2 or section 2. Once you've got that, we're going to go to, who doesn't have that capture pasted in yet? Who's still working on getting the capture? Anybody? Okay, so everybody's got the capture. Go to the paragraph on my screen that says answer the following questions. Go to the end of that paragraph that ends with you need to answer the question. And let's just press enter a couple times on there and get to the next page. And that's where we're going to paste in our evidence. But we need to open up the TCP trace file for 8.0. So I'm going to go over to Wireshark. I'm going to go up to the very top. I'm going to say open. But right now it's pointing into my 8.1 traces. So I need to come up a level, select, let's see, where is, I'm still in 8.1. Am I still in downloads? I'm not in downloads. Where's my downloads folder? There's my downloads folder. There's my 8.0. Okay, now I can scroll down until I see I've got one TCP trace file, one packet capture, it's TCP. I can select and open that. And I'll continue without saving. Now, they used the same IP address in their capture, so my filtered view still works. I don't really need to have that filtered deal. All I really need is what I can follow their instructions. I don't have to really have it filtered right now. But what we want to do is I want to go into Wireshark, and you can see packet number 1 should be the first SYN, where we're establishing that connection. Packet number 2 is our SYN-ACK, and packet number 3 is the acknowledgement. That three-way handshake is established. We're connected. What we want to do is find the HTTP post packet. So if I scroll down my list of packets, it's right there. It's packet number 199. I'm going to expand out Hypertext Transfer Protocol. I'm going to expand out TCP, and I'm going to expand out IP protocol. So I've got detailed information about IP addresses, ports, and HTTP. I'm going to highlight that packet number 199 again, and I'm going to go up to Edit, Copy, All Visible Items, or you can simply press Control-Alt-Shift-A. And I'm going to paste that into my document. I'm going to press Enter twice. I'm going to go back to Wireshark, and I'm going to find the OK response. And I'm going to do Control-Alt-Shift-A and paste that into my document. Let me know when you've got the expanded evidence for the post and the OK HTTP message. It's all thumbs up from Levi. Anybody else got it done? Laura is good. Jason, good. Thank you, Bradley. Anybody else done? Thank you, Jose. Or Minor. Good, Kyle. John, you good? Fabian? Yes? Okay, perfect. So, our first question is, what is the IP address and TCP port number used by the client, that's us, that is transferring the file? Who can tell me the port, the TCP IP address? What's the IP address of the client computer that's sending the file to the web server? Levi. Yep, it's right there. It's right there in our evidence, right? What port number is it using, Levi? It's using, our client computer is using port 80? 1161, because remember, we're not running a web server. We're sending to the web server. Our first question's done. Who can tell me what the IP address is of the web server that we sent to? Nobody? Minor? Right, it's right there in our evidence, right? This is too easy. And we already know what port number it is, right? What port number is it, Minor? Port 80, because it's running the HTTP web server. The first two questions are already done. Now, we did not do this. We're doing this with their capture, so we're going to ignore question number 3. Now, remember, this is all about TCP. So we're going to forget about HTTP now. We're going to go up, we're going to make a settings change in Wireshark. Up in the command menu on Wireshark, we're going to select Analyze, and then we're going to go down to Enabled Protocols, and we're going to disable HTTP. So in Wireshark, Analyze, Enabled Protocols, and you go, wow, that's a long list. If you simply type in HTTP on the top, right there's anything that has to do with HTTP. Right there in the middle of the screen where it says HTTP, I'm going to uncheck that. And I'm only going to uncheck that one. And then I'm going to click OK. Everybody got that? Anybody still trying to find it? You're good? All right, I'm going to click OK. So you can see it changed. Those HTTP post and OK packets, they're not being displayed anymore. So now what we're looking is simply the sequence of TCP packets. They're segments of that file that we sent, because it couldn't all be sent as one piece. It was too big. We don't do that because what if there's a problem with sending it, the entire transmission has to be resent. If we're sending, oh, by the way, who can tell me how many segments it took to transmit that alice.txt file to the web server? It's in your evidence that we pasted in. Everybody should be scrolling through their document right now, looking at the evidence that we pasted in. Who can tell me how many TCP segments it took? What do you see, John? Okay. So it's going to be in the post where we're sending, right? Up until now, when we've been looking at these expand packet details, we see the IP information, we see the port information, we see the protocol information, but this one's got a little bit different perspective. It's got another line in there. Anybody see something about TCP segments and a number? Bradley? Right there. 122 reassembled TCP segments. And it doesn't list them all here because I take up a little bit too much space. But Wireshark also references the packet number that it gave for each one of those transmissions. So that alice.txt file was transmitted in 122 different segments and then reassembled on the other end. Who can tell me how large that transmission was? Jason? How large a file did we transmit? Is it more than 50 bytes? That particular segment that we were looking at was 50 bytes. The whole transmission was 164,000 bytes. Information's all there for you. Let's take a look here. Let's continue on. What is the sequence number of the TCP synchronize segment that's used to initiate the TCP connection between the client computer and the web server? I don't see any SYN packets there, because it's going to tell us right in the info, right? Where's the SYN packet? Where's that SYN packet that we use to initiate the communication? Well, if it's used to initiate the communication, Bradley, what packet number did Wireshark label it as? Packet 1. It was the start of the communication. It's what we used to start that handshake. So what's our answer? But you remember, it's not asking for the packet number. It's asking for this sequence number. What's the sequence number of that SYN packet? Adam. Huh? Yeah. Yeah, right there. Sequence number 0. Because we start counting at 0, right? The other half of that question is what is in the segment that identifies it as a SYN segment? I don't know about your screen, but it's already highlighted on my screen. The flags in it. The flags identify it as a SYN segment. And more specifically, we can see the bit that's turned on that specifies it as a SYN segment. I'm going to simply highlight flags, hit Control-C, and paste it in. Remember, we're identifying the sequence number, not the number of the packet for the packet that Wireshark applies to it. Sequence number. So question number 5. Who can tell me what the sequence number is of the SYN ACK segment sent by the web server back to the client? Fabian? Anybody? Minor? Yeah, it's right there. Sequence number 0. What's in that segment? Minor. What's in that segment that identifies it as a SYN ACK? The flags. And specifically, what in those flags tell us that it's a SYN ACK? The bits being turned on in that set of data. The bit is set for acknowledgement, and the bit is set for SYN. There's no other bits that are set there. Now we got to put our investigator cap on. Our question number 6 says, what is the sequence number of the TCP segment containing the HTTP post command? not the HTTP packet, but which is the TCP segment that contains that post command. How would I find that? Well, would it be in our SYN-ACK? That's simply establishing the three-way handshake, right? If I select the ACK where we establish it, and I'm looking at my details in the very bottom, I don't see anything there. What about the next packet? Kyle, see anything in that next packet that relates to the post command? And a web page? It's right down there in the bottom in the details, right? In fact, if we scroll down, if I select data, look over here. Right there, post, Ethereal Lab, Lab 3.1 reply.htm, HTTP 1.1. There's our post command and the packet, the sequence number that it was sent in. So we discovered Wireshark's labeled it packet number 4, but who can tell me what the sequence number is for that packet? Where is? Yeah, the sequence number. Sequence number 1. We established our communication. Now we're starting our transmission. It's a new sequence. There's our answer to question number 6, or yeah, 6. Now consider that segment that contains the post command. Consider it as the very first segment in that connection. That's the first where we're initiating the transfer of the information, right? What are the sequence numbers of the first 6 segments in the TCP connection, including the segment containing that HTTP post? Segments. What are the sequence numbers? How would we find that? Well, if this is the first one, right? So we know that the very first sequence number is 1. Is that correct? We already answered that, right? So it's because it does say, including that first one. So what I'm going to do is I'm going to do this. I'm going to do packet for sequence 1. They say they want the first 6. Look at the text that you have highlighted. If you've still got packet 4 highlighted and you've got sequence number 1 highlighted, Is there anything in there that tells you what the next one is? John? Yeah, it's as simple as that. It tells, it indicates, hey, the next sequence number, this is telling it how to reassemble it. Next sequence number 566. So where do I see what packet number did Wireshark label as the packet that has sequence 566? Just look in the info section in the very top. Yeah, packet number 5, right there. So packet 5 and its sequence 566. Well, if I select that next packet, do you think it tells me what the next packet after that is? What do you think, Levi? Yeah, it's right there. What's the next packet, Levi? Hey, 2026. Where do I see packet 2 or sequence number 2026? What packet number? Kyle. Packet number 7. Packet 7 is sequence 2026. Where does it go from there? Jose, what's the next packet after that? Or next sequence number after that? And what packet number does that correspond with? Packet 8. Fabian. So if our next sequence number is 34, or if our sequence number is 3486, what's the next sequence number after that? So I've got packet 8 highlighted with it, which is sequence 3486. What's the next sequence number after that? 4946. And where do we find that sequence number listed? In packet what? Packet 10. So packet 10, sequence, and that packet was 49, or the sequence was 4946. So we've got 5 of them. John, what's the next packet after that, or the next sequence number after that? 6406. And what packet did Wireshark label that as? It tells us the next sequence number is 6406. And if I look in the info section in the top, it shows me that sequence number contained in there. Do you see the next packet that says it's sequence 6406? If you've got packet 10 highlighted, see how that shows SEQ equals 4946? Packet 11, yeah, just that simple. The packet 11 is sequence 6406. So we've detailed the sequence number for each one. So the one thing that we also are looking at in this is a thing called RTT, which is round trip time. How long did it take for us to get the acknowledgement back. So this takes some calculations. This is going to be the longest section of this lab. To be able to do this, I'm going to move my data up to the top of my word. I'm going to move this down here. And I'm going to go back to packet number 4. My time, the time on my packet, on my Wireshark display shows the time that they did the transfer. That doesn't give me a lot of information. I want to change the time display. I want to see seconds from the start of the capture. So I'm going to go up to View in the command menu. I'm going to go down to Time Display Format, and I'm going to select Seconds since beginning of capture. Shortcut is Control-Alt number 4. You can do that as well to change that. Or View, Time Display Format, Seconds since beginning of capture. And now we can see it displays starting at 0, how many seconds after the beginning of the capture. So we have to understand that for each transmission, there's a corresponding acknowledgement of that receipt of that transmission of the packet, right? So packet number 4 was the very first one that we transmitted. That was the establishment of the communication. Let's see here. That was the push. But if you look in the packet details, and I've got that highlighted down in the bottom, that's simply the communication between the web server. That was not the start of the data itself. Packet 5 was. That was at sequence 566. If I scroll down in those details in the very bottom, and I can start to see the text of Alice in Wonderland. So that transmission started at 0.04173 seconds. Sequence 1, or sequence 566, was it should have a corresponding acknowledgement from the web server. Does anybody see that? Does anybody see an ACK 566? What number is it, Levi? Packet 6. Packet 6 was the acknowledgement to that transmission. So we need to do a calculation. What I'm going to do is packet 5, the ACK was at 0.053937 seconds. The sequence that sent it was at 0.041737 seconds. My round trip time equals when the acknowledgement was sent versus when the sequence was sent. If I open up calculator, and I do 0.053937 minus 0.041737. There's my round trip time from the time that the sequence was transmitted till I got the acknowledgement back. So I'm going to hit Control C and copy that, and I'm going to paste that into my document with the word seconds after it. See how this works? We transmit a segment, segment's acknowledged. It took 0.0122 seconds to receive that acknowledgement. So our next segment is 2026. Does anybody see the acknowledgement 2026? What packet was the ACK equals 2026? Right, Wireshark identified it as packet number 9. So my ACK came back at 0.077294 seconds, which corresponded to the sequence being transmitted at 0.54026 seconds. What's the difference? What's the round trip time for that? So 0.077294 minus, let's see, which one was it? 5026, 54026, 0.054026. There's our round trip time. Took a little bit longer. How about our next one? We might need to scroll our list of packets up a little bit. Sequence number 3486. Where was it acknowledged? What packet number was the acknowledgement 3486? Packet number 12. And we can see that that was acknowledged, that that time was 0.124085 seconds. And the transmission of that segment was at 0.5469 seconds, 0.054960 seconds. Do the round trip time calculation. Took a little bit longer. Ooh, how did I get a negative there? 0.124085 minus 0.54690. Oh, that's why. that what you got, Jason? 0.69395? Let's do the next one. Where's the acknowledgement of sequence 4946? Anybody see it? Adam? Anybody? Where's the ACK equals 4946? Wireshark identified it as packet 14. So here again, ACK, and that time period was 0.169118 seconds, which corresponded with the sequence being transmitted at 0.077405 seconds. Do the round trip time. Everybody get the same number? And then finally, our last one. Anybody see the acknowledgement for sequence 6406? Levi? Number 15, yep, next one right after it. So ACK in that time period was 0.217299, which corresponded to the transmission of the sequence, which was at, that was 6406, was at 0.7815 seconds. Do the round trip time. Almost half a second on that one. Over half a second, right? Seems like it should have been a larger value than that. $217,299 minus 0.078.157. That's more like it. Okay. Everybody on track? Anybody need more time? All right. Okay, so Wireshark's got a great amount of tools, just all sorts of different tools that's built into it. go to, in Wireshark Statistics, TCP Stream Graph, Round Trip Time Graph. So Statistics, TCP Stream Graphs down towards the bottom, Round Trip Time. You know, well, that's an interesting graph. Put a check mark in the middle at RTT by sequence number. And then on the right-hand side, select switch direction. That's a little bit more interesting. That shows us the transmission of each one of these segments as they're occurring. Everybody have this display that looks like mine? Click Save As. Change the Save As type to PNG. And then name it RTT. And click Save. It should be, it's going to either be in your Wireshark Traces 8 file, or I'm going to put it in my downloads. Note where you're saving it. Once you've saved it, close that graph. Go back to your document, and we're going to paste it in. So I'm going to go up to Insert, Picture. From this device, I'm going to navigate to it. There's my saved image. I'm going to insert. And there's my graph showing the transmission of those packets. Okay, so we've got our graph. Well, that's good visual, right? How much data were we transmitting? Question number 8 asks, what is the length of each of the first segments? Each of those first 6 segments that we were looking at. If I come back over to Wireshark and scroll back up to the top, we said number 4 was our first initiation of that transmission, right? See, right in the middle of the screen is length. Packet number 4, what was the length in bytes of packet number 4? Anyone? Levi? How much? $619 bytes was the length. Remember our list of packets, right? Packets 5, 7, 8, 10, 11. So I'm going to type that in. Packet 5, packet 7, packet 8, packet 10, and packet 11, right? Well, if I move this up, here again, I can move my document down. What was the length of packet 5? Staring right at you. What's the length of packet number 5? Come on, someone. Minor. 1,514 bytes. How about packet number 7? Any different? 1514 bytes. How about packet number 8? Do they change at all? The rest of them are all 1514 bytes in length. And typically that's the largest any packet will ever be. You'll notice that is the largest any of those packets ever get. Now, there's also a thing called buffer space. The question number 9 asks what is the minimum amount of buffer space advertised at the receive, that's at the web server, for the entire trace? What's the minimum? Well, we need to start looking at maybe something from the sender, right? That be from the sender or from the receiver? Where would that be? You think you'd find that information in Wireshark? In your packet information? Let's start looking through some of these things. We got that first send. Well, is it going to be under IP information? No. It's not going to, IP is not going to tell us anything about that. Would it be in our port information? Maybe. What about from the, still sending to the sender, right? What about back from the web server? Looking around, right? Look at the packets that you're sending. I'm down here in number 14. See window? Calculated window size? Let's go back a little bit. The one before it. Look at your info right here. Window size, window size. This is what they're responding back, telling us, right? That was the ACK to 3486. What's the minimum window size that it shows there? When we're transmitting, when we first start transmitting, what's the calculated window size? This is the amount of buffer that's available, 6780. The window began 67. That's all the smaller it was. We already established, remember at the beginning, the whole file that was transmitted was 164,000 bytes. Remember that? The buffer started very small. Did it stop us from transmitting that file? It did not. No, it did not. Why? Why didn't it? Did the buffer stay the same size? Did the window stay the same size as those 122 packets were being sent? Did the window stay the same size? It's a simple question. Bradley. No, it continues to grow as we're transmitting. Look, 55,480, 58,400, 62,780. It understands, hey, I'm getting a big file. I'm going to keep growing my buffer. 62,780. 70,000, 72,000, 77, 80,000. It grows in response. It did not. The buffer continued to grow. Okay, this is our last question. Are there any retransmitted segments in the trace file? How would you know if there were? I mean, you could go sit there and look through each 122 transmissions, right? But take a look at the graph that we created. Do you see in that graph anywhere where the graph goes backwards, where a packet would have had to have been transmitted? Or does each step continue to move forward? What do you see on my graph? Do you see anywhere where it went backwards and appears to have resent a packet? I see a head shaking no, thank you. If you did, you would see it there. Every transmission was successful. So are there any retransmitted segments? No, there are not. And we examined the round trip time graph. Save your file, upload it to Dropbox, and our lab is done.